Hey guys, Mr. Enyart here. Today's lesson is going to be from Eureka Math. It is Topic D, Lesson 11 from Module 4. We're going to be focusing on using the distributive property to write equivalent expressions, and we're going to simplify them using the greatest common factor of the coefficients involved, but we're going to keep in mind how it affects the variables involved. So I'm going to go over all those words and simplify things for you and go over lots of examples. So feel free to pause the video whenever you want, rewatch what you need, and try to work ahead in order to see if you are figuring things out, and then compare my answers to yours and see if you got it right or wrong, how you can change or adapt or continue doing what you're doing if things are going well. All right, stick around. Let's do some math.
So I'd like to start by describing the distributive property with these two models. This is from Eureka Math again, Module 4, Topic D, Lesson 11. So comparing these two models is what I did with my class. You notice right away that both of the models have the same amount of quantities. They both have two 5s, just in different orders, and they both have two 3s, also just in different orders. So the two models are equivalent, right? They both will have the same total answer, which of course would be 5, 10, 13, 16, 5, 8, 13, 16. So they both have 16, but they're written in two different ways. And what you notice with this top one, as we kind of zoom into it here, is we have two groups of 5 and two groups of 3, and we are combining them. So we would write that numerically as 2 times 5 plus 2 times 3. And that's going to give us the answer of 16, right? Because 2 times 5 is going to be 10, and then we're going to add that to 2 times 3, which is going to be 6. And, of course, that gives us 16. So let's see if our other model gives us that same amount. So we come down here, we look at this we found is equal. So now I don't see multiplication up top, I see 5 plus 3, because I have 5 and 3, and 5 plus 3. So what I notice is I have two groups of 5 and 3. Aren't these the same thing, right? It's two of them. So I can write that as two groups of 5 plus 3. Now according to Pemdas, if I'm going to solve this, the first thing I'm going to do is I'm going to do 5 plus 3. Which is 8. And then I still have my 2 out here. So this, of course, is the same as 2 times 8. That's what 2 parentheses 8 are, which, of course, is 16. So we do see that they have the same value. Now, how are they equivalent in using the distributive property? That is beneficial, is easy to see when we put them together like this. We're going to say that these equal 2 times 5 plus 2 times 3, which was from our model above. And I want you to notice that 2 parentheses 5 means 2 times the 5. So we're literally distributing this 2 to the numbers inside the parentheses. So this would be 2 times 5, which is right here. And this would be 2 times 3, which is right here. And then, of course, we just put that plus sign right back in the middle. And that's how we distribute the 2 to what's inside the parentheses, because the parentheses is another symbol for multiplication. So now we're getting involved with these that involve numbers and letters. But in math terms, we don't say letters and numbers. We say coefficients and variables. So the numbers you see are called coefficients because the definition, I highly recommend you pause the video and write this stuff down in a journal. The coefficients are the numbers in an equation or an expression that is next to the variable. So the 6 because it's by 6x and the 9 because it's by 9y. The 6 and the 9 are the coefficients. Now a variable is the unknown quantity in the equation or expression, and that's often represented by a letter. So x and y are variables. Having that said, we want to simplify this and write it with using the distributive property. So the first step we're going to do is we're going to find the greatest common factor of 6 and 9. Now, if you know your math facts, this is pretty simple. If not, write the two numbers down, put your semicolons, and go through all the factors. Factors are the numbers you multiply to get a product. So it's factor times factor equals product. So when 3 times 4 equals 12, 3 and 4 are both factors. All right, so the factors of 6 include 1, 6, 2, and 3. Because 1 times 6 is 6, and 2 times 3 is 6. The factors of 9 are 1, 9, and 3. Because 1 times 9, 1 times 9 is 9, and 3 times 3 is 9. So what is the greatest common factor? The one they both have in common that's the greatest, and that's a 3. So I write the 3 outside my parentheses, and then I put the parenthesis, and I'm going to next divide my coefficients by that greatest common factor and write what's left inside the parentheses next to the appropriate variable. So 6 divided by 3 is 2, and that went with x, and then I put my plus sign. And then 9 divided by 3 is 3, and that went with y. So my equivalent expression for 6x plus 9y is 3, parentheses, 2x plus 3y. Because I would distribute the 3 to the 2, 3 times 2 is 6, and the 3 to the 3, which would create 3 times 3, which is 9. So you can see why they are both equal. So in this example, we notice that the variables are the same. Now, when the variables are the same, we've learned this in previous lessons and in the sprints, it can basically be replaced with the word apples. So C and C can both be apples, right? If I had 3 apples and I add 11 apples, how many apples are there? Well, there's 14 apples. And that's it. These ones are really simple when we have the same variable. The coefficients can just go through the operation that's attached to them. So this would just be 3 plus 11, and then that would give me the total number of apples. And that makes sense because if I made a tape diagram, I would have 3 apples, or 3 C's, so of this amount, and then I would be adding 11 more of that same amount to it, so that would be a total of 14 of the boxes that have that same amount of C. So it's 14 C's. And our last example is one that only has one variable. This would not necessarily be a coefficient. This is just a number that needs to be added to whatever I get from this. And it's separate because it has no variable. So it's going to be important. But I'm going to start the same way. I'm going to find the greatest common factor. And of course, the greatest common factor is, ding, 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 8. I can divide 8 by 8, and I can divide 24 by 8. So what I would do next is take my 24, divide it by 8. Of course, first I have to write my 8 in my parentheses. So, sorry. Take my 24 divided by 8, I get 3. And that goes along with B. I have to put my plus sign. And now I'm doing 8 divided by 8, which of course is 1. And I like that down here they ask the question, why is there a 1 in the parentheses? Because a lot of people are going to say, well, you don't need that 1, it's a 1. And they're going to say that because they've generalized the fact that we've been multiplying, and when you multiply by 1, it doesn't change the number. However, this isn't multiplication. This is addition. When you add 1, it is going to make a difference. If I had $25 and I got one more dollar, I would have $26. That's a different amount. So therefore, I need this plus 1 because it is going to change my outcome. So the last thing I want to do is just go over one of these examples where we have a variable and its amount given to us, and we prove that 14x plus 2 and 2 times 7x plus 1 is the same thing. So I'm going to work both problems, right? I'll work one in blue, and I'll work one in black, so you can see the differences, and that I'll get the same, I should get the exact same answer, because the distributive property is a property. And to be a property, it means it works every time. So let's go ahead and, in the blue, plug in the 10 right here on this one. So this would be 14 times 10 plus 2, which of course is 140, plus 2, which of course is 142. And then in black over here, let's do this one. So we have 2 times 7 times 10 plus 1 in parentheses. So I have to do 7 times 10 first, which is 70. And then I have to do 70 plus 1, which is 71. And I'm taking that times 2. And if you do 2 times 71, you're going to get, that's right, 142. And so you see, I do get the same number. Both are equivalent expressions, and I can prove them when I'm done. If I really want to check, if I'm not sure that I did it right, plug in an easy digit, an easy number, for your variables. So I like to use 10s and 5s. I stay away from 2s, 1s, and 0s because they change things and sometimes mess me up. But 5s are easy to multiply, 10s are easy to multiply. I like 3s. 3s are pretty small and change things. You know, some people like to use 11s because 11s are often pretty simple. But 10s and 5s work really great to plug in and try.
I hope this was clear enough for you guys. Lesson summary right here. An expression in factored form is a product of 2 or more expressions, and it's said to be factored because you're using the greatest common factor to take those coefficients down. We're using the distributive property, and we're finding equivalent expressions to simplify our life. Hopefully this helped you out. Leave a comment below or give me any suggestions if you'd like to see some different things. If you have any topics you'd like some help on, please feel free to put those in the comment section. I'd be happy to make videos on that. Have a great day and keep rocking that math stuff.